everyone, and welcome to IoT Forge Unplugged. Every 2 weeks, we bring you the most exciting news from the world of IoT in this short podcast, where I break down the latest updates and trends. I'd love for you to be part of the conversation, visit sharing feedback, suggesting stories I might miss, or just discussing these developments with the community. So let's get started. Today is March 4th, and this is our 5th episode of 2025. ESPHome has rolled out an upgrade to the ESP32C2, also known as the ESP8684. This update brings improvement in memory, storage, and overall performance, making it a more capable choice for compact and cost-sensitive IoT applications. The ESP32C2 is designed for scenarios where low power consumption and affordability matter. It's commonly used in smart home devices, simple automation controllers, Wi-Fi enabled sensors, and basic industrial IoT applications. If you're looking for an entry-level chip that balances cost and functionality, this is one to consider. And with this upgrade, it just got better. ESPHome continues to evolve, with the latest version, 2025.2, bringing new integrations, bug fixes, and optimizations. If you are running ESP-based home automation, this upgrade introduced better support for devices and more customization options. I have to say, I'm a big fan of ESPHome. It's one of my favorite tools for home automation, and I always look forward to testing new features. This update expands support for audio components, enhancing voice assistant applications. Specifically, new speaker components have been introduced to provide more advanced functionality when using the voice assistant component. These components extend ESPHome capabilities, helping you create the ultimate personal voice assistant hardware. If you are into DIY smart home projects, you'll definitely want to check this out. Now let's talk about one of the most common serial bus in IoT world, I2C, I2C. Or more precisely about its next generation, I3C. If you are familiar with I2C, you know it's been a core protocol for connecting sensors and peripherals in embedded systems. But now we have I3C, a next-gen alternative designed for faster speed, low power consumption, and enhanced multi-device communication. Recently, I started exploring smart farming and tested various I2C sensors for monitor soil, temperature, and humidity. However, I encountered a significant limitation. Traditional I2C communication struggles with distance due to bus capacitance and signal integrity issues. Typically, I2C is best suited for short-range communication, with practical distance often limited to a few feet, especially at high speed. I originally hoped I3C would solve this, but after digging deeper, it turns out that I3C's improvements focused on speed, power efficiency, and multi-device communication, not necessarily extending the physical range. While I3C allows higher data rates and better bus efficiency, its effective communication distance remains similar to I2C. For applications required longer communication distances, alternative protocols are worth considering. RC885 can reach up to 1200 meters and is widely used in industrial environments for its noise resistance. CAN bus is another robust option, offering reliable communication up to 40 meters at 1 megabit per second, with longer ranges at lower speeds. And Ethernet can cover up to 100 meters with twisted pair cables, providing high-speed, stable data transmission. For smart farming or other long-distance sensor network, choosing the right protocol can make all the difference. If you're experimenting with extending I2C or using alternatives, I'd love to hear what worked for you. The next topic I choose for today's episode is EdgeAI for predictive maintenance in CNC machines. Tormac CNC machines are getting a boost from EdgeAI, helping detect issues before they cause failures. This is an exciting step for industrial IoT, bringing intelligence to the edge for real-time monitoring and predictive maintenance. This is something I've been dreaming of implementing on my own DIY CNC. Imagine running a machine with built-in intelligence that warns you about potential failures before they happen. It could save time, materials, and even prevent catastrophic failures. I am currently exploring ways to integrate similar predictive maintenance into my setup, and I love to share my progress with the community in the near future. To the next topic. Energy harvesting is a game changer for IoT, and Silicon Labs XG22E Energy Harvesting Explorer Kit makes it easier to build battery-free IoT devices. This technology captures energy from light, temperature difference, or RF waves, reducing the need of traditional power sources. The kit itself includes an energy harvesting power management IC, ultra-low power Bluetooth system on chips, and multiple harvesting options including solar, thermal, and RF energy sources. This opens up possibilities for applications where replacing or recharging batteries is impractical, like environmental sensors, industry monitoring, and wearables. Are you heading towards a future where IoT devices run indefinitely without batteries? This is a trend worth watching. The Matter protocol is gaining traction, and now Arduino and Silicon Labs are making it even more accessible with EdgeAI and machine learning. This collaboration aims to simplify smart home device development while ensuring seamless interoperability across platforms. What's exciting is that this isn't just for large-scale manufacturers. Hobbyists and makers can also leverage these technologies in their own projects. Whether it's a custom smart home sensor, an intelligent pen feeder, or an AI-powered security device, the potential applications are huge. If you have been looking for excuses to dive into Matter, this might be the perfect opportunity to start a new pet project. No doubt, every product gets better if marketing team put a mentioning of AI into announcement. Okay, let's come back to the real engineering and talk about concurrent multiprotocol, a crucial technology for devices that need to communicate over multiple wireless standards like Bluetooth, Zigbee, and Thread. Why does it matter? Imagine a device that seamlessly interacts with a Bluetooth-enabled smartphone while also communicating with the Zigbee smart home hub. Instead of switching manually between protocols, concurrent multiprotocol support allows devices to operate across multiple standards at the same time without conflicts or delays. Silicon Labs has published an in-depth guide on this, and if you are interested in wireless communication, I highly recommend checking out their blog. It's a goldmine of knowledge, but be prepared, it's pretty technical. If you are an engineer working with IoT networking, or if you are curious about how multi-protocol IoT devices can work in real-world application, it's definitely worth a read. And that is it for today. We explored the ESP32C2 upgrade and where it fits in real-world applications, the latest ESPHome update with expanded audio support, and how I3C compares to I2C, along with better alternatives for long-distance communication. We also looked at EdgeAI for predictive maintenance, energy harvesting for Ambient IoT, and how Arduino and Silicon Labs are making Matter more accessible. Finally, we touched on concurrent multiprotocols and why they are worth exploring. As always, you can find all the links to the articles and news in the podcast description. What are your thoughts? Which of these developments excited you the most? Do you see the potential application for your own projects? Let's discuss. If you enjoyed this episode, hit like and share it with your colleagues. Join IoT Forge, stay curious, and have an amazing day. See you next time. Bye bye.